Good morning and welcome to this session number 17 of 24 Hours Have Passed. Today we are going to do a session on patterns and practices for scaling Microsoft Azure SQL Server. Our presenters today are Scott Klein and Sean Tinlin-Jones from Microsoft. Before we do that session, we were just going through a few specific items. We can go to the next slide, please. Oops. If you have any technical assistance requirements, please do let us know. We will be able to help you. If you do find you do not have any sound, please try and reconnect. That usually would fix the problem. You want to maximize your screen. There's a zoom button at the top of the presentation window. If you have questions, please do ask those in the question tab. Make those in, and we will answer those as we go through the session or towards the end of the session when we have our Q&A section. Next session slide, please. We obviously need to thank Microsoft for being the host presenters of this session today, and without them we wouldn't be able to provide this excellent content for you and all the speakers that they've provided for this. Thank you very much to Microsoft. Next slide, please. For those of you who can attend and would like to attend, Microsoft Summit is in November in Seattle. There's a price change on the 27th of June. And it's going to go up a little bit, so you can get in before then. That's great. There are discount codes available for your local chapters, $150 off the current registration price. So I do recommend you try and get registered before that time, and also you contact your local chapter for that registration discount. If you need more information about that, please do send us a message about that. And the final slide, please. So I'm going to pass now over the controls to Scott and his colleague Sean, and hopefully enjoy the presentation, and we will speak to you guys later. Sean, over to you guys. Thank you.
Well, hey everybody, it's indeed an honor to be here and to present to you. Just want to introduce myself, and what I'm going to do is turn the time over to Sean to introduce himself, and then move on with the presentation. Sean has graciously I've been working with Sean for a while, and Sean has graciously volunteered to help and with me with this presentation. So we'll turn the time over to him. So I'm a senior technical evangelist for Microsoft, and I get to talk about all this awesome SQL or data platform stuff, including SQL Database. This is exciting, and one of the things we've been working with Sean on is these patterns for database sharding. So enough about me. What I'm going to do is, Sean, I'm going to turn the time over to you. Why don't you introduce yourself, and let's make this happen.
Okay. So name is Sean Tinlin-Jones, and I'm part of the Azure CAT team. And what I've been focusing on for the last while has been on scaling up relational database systems. Our team focuses primarily on working with customers who are pushing the edges of our technology, our Azure platform. And one of the questions that's been asked a lot by customers is, how can we truly be elastic scale for databases? And what is our responses to such things as federations? And we promote custom sharding, and this is one pattern, one sample approach to do elastic scale, where you can scale out and scale up. There we go. Scott, you there?
Yep. So thank you. So let's jump into we have a few slides before we get into this. Is going to be very demo heavy, thanks to Sean. So let's jump into the slides and just kind of build the foundation of what we're going to talk about.
Okay, excellent. So really the focus of the pattern today when we were tackling the subject, we were saying, let's not only scale out, let's also scale up, or up or down, scale out and in, so we needed that, right? And with the latest SKUs that are out there, scaling up and scaling down is much easier than what we had in the past for a relational database. So, but the out and in is still a challenge. And when we're talking about out and in, that real challenge is around splitting and merging. How do we bring data back together, and how we separate them out? We've seen splitting before. We saw that in previous releases around this subject, but merging has always been a challenge. and this pattern addresses that. Along with scaling, you have to scale out data as well as the schema of databases, and the pattern addresses that. So if you've got 100 shards out there or 100 databases out there, how do you propagate the fact that you want an index to be on a table? How do you propagate that you want this table that exists in all those databases to be found in all those databases? And as we go along, we will see that data is, in some cases, the data needs to be copied to all the databases. And we call that reference data. We'll talk about the terms as we go along. But that data, how do we propagate that? And then lastly, database provisioning. Some custom sharding, what we do is the databases are provisioned up front. The pattern that we have here is where the database can be provisioned for the solution in an automatic fashion, if you will. Scott, you're going to jump in with anything that you need to add.
Yeah, so I was just going to say, so I like the ability, one of the challenges that we had with previous was, like you mentioned, the ability we could split, but we could not merge, right? And so there was a lot of challenges around with the previous. And what we're going to see today is the ability to kind of the patterns that allow for the elasticity, the scale out, scale in, scale out, right? And
yeah.
That's what I'm really excited about, is it solves a lot of the problems that we had earlier.
That's right. That's right. So before we get really into it, we're going to throw words around and terms around. So we put this diagram together so that we could just get everybody on the same page when we reference these terms. So the big thing here is that we have what people might call a tenant, and a tenant really is a collection of records in a business term. So a customer will be a tenant, right? But when you're inside a database, that collection of records would be something that we call a shardlet, because sometimes when we group the records together, it's not about a customer, it's not about a region. It could be something as esoteric as sales orders, because you want to distribute the load. So we've called that a shardlet. And as you can see here, in this particular case, the shardlet happens to be a customer, and the customer has a set of data. A shardlet resides inside a shard. So a number of shardlets, one or more, resides inside a shard. And that shard actually sits on a database. So there we are in the shard. When you have multiple shards, then we have what we effectively call a shard set. And a shard set is a data model that is identical in each one of these shards. So this particular shard set in orange is actually a different data model. And this blue one is a different data model. Then so that's a shard set. In each shard we'll have a reference table. And the difference between a reference table, if you can see the mouse there in the left-hand bottom corner, to a sharded table, which is these are called sharding tables, is that these contain the shardlets. They have a sharding key, and that's by customer. You can't in this table shard it by customer because it's actually a data center or a region, a city that we've got here. And the sharding tables have a sharding key. I think that covers this covers the terms that we will use as we go through the demo and as we go through the rest of the discussion here. Anything you'd like me to call out there, Scott?
I think this is some of these concepts are fairly. I think people might be to have a challenge with some of the new technology, but I think it's familiar enough with a lot of people. Shards and what the partitioning key is. I think they're familiar with that. Shardlets might be fairly new, but I think this is a great foundation, a great introduction to how kind of the terminology of how these patterns and practices apply to the components that apply to these patterns.
Yeah. So what you find when we're doing the data modeling, and today there are a number of challenges, and today we're not going to go into each one of these data points here or these topics in great detail, but we wanted to bring this to your attention about the experiences we've had with customers. So when they want to do sharding, the first thing that comes to mind is things like how do you do, an even data distribution. Another one might be where we're going to place the shards. Some of these are pretty easy to think of, if you will. But as you go along with the design, you start saying, well, how do I get a globally unique sequence ID? My data model needs that, right? Or how do I actually propagate the data, the schema changes? If I've only got two databases, not too bad. I'll do a little script here, connect to the database, do that there, script to the other one. But when you've got multiple databases, managing that becomes challenging. My apologies for that. I thought that that was disabled. Identifying appropriate keys is a big topic when one takes on these challenges here. Now, the pattern that we've got that we're going to share with you today is addressing pretty much all of these topics in some form or another.
Yeah, and a lot of these, if they've done, if they've ever built, their own, tried to build their own elastic scale out, they've run into these. Right? There's a lot of these are like moving data, altering a table amongst all the different shards, right? The DDL propagation. A lot of these are challenges, and we'll see how this, in the demo, we'll see how this works. But these are, what I really like about this, the patterns that we're going to show is it really solves a lot of these, if not most of these, or all of these challenges.
Yeah. And just two more slides before we get down to the demo, just to help with understanding of how we put these libraries together. These are code libraries where the patterns for data elasticity is a bunch of contracts that we believe have worked and we've seen work with customers, and they're necessary to get custom sharding in place. But the reality is some folks will place all of those contracts, these interfaces, into a SQL Azure implementation. To suggest that a SQL Azure is a little bit of a misnomer, because this logic actually can currently, as it stands, can work on an on-premise SQL as well. Though all the development was targeted to SQL Azure, the work we've been doing has proven that it succeeds on a local SQL implementation too. And there are some aspects where, even though this is about relational data store elasticity, there are some objects that we use, or data store capabilities like key value pair, metadata information that can be stored in a table store. You may find that table store doesn't work for you, so we created a separate library if you wanted to. This can be extended to put there a NoSQL database, something like an HBase if you wanted to, you could put there. And lastly, this section here, this contrib, is a little bit out of place, but what he is here is those things that are not specific to sharding and custom sharding, but are useful for achieving your ends. So to give you an example, we know that sharding, here's a shard map, all that will be here in the SQL Azure. That's what we've done in our pattern. We've done a combination of these two. But in the pattern, we leverage SSDT, SQL Server Data Tools. Fabulous tool. The truth of the matter is it's not about custom sharding. So it's a contrib, and we've written code there to share, done a sample of how SSDT fills the gaps of propagating databases. But there are some parts of SSDT that just don't fill that gap. So we've added code to compensate for that, and that's in that library. Lastly, this city hash library here, the tiniest thing ever. Basically, there are ways that you can distribute your data, and we happen to use city hash in our pattern, in our sample, for helping us distribute the data. These are really the core libraries that you are looking for when you are implementing custom sharding. Far more to be said, Joe.
Yeah, and the key here is that these are, like you said, these are extensible, right? This is a great place to start, but if you want to extend these, you can certainly do that.
Yeah, you could actually, you need this part here, this top part, but the rest of the stuff you can create your own. We've provided a lot of best practices and lessons learned in what we're providing as a sample, but to Scott's point, you can create your very own.
Right. So awesome. So let's jump out and let's see how this stuff works.
Yeah, one more thing. This is what
that's right.
this is the sample shard metadata model that we've got here. So remember, I was in the library, we were referring to that SQL Azure library. This is the model that we use to store inside the database. The metadata is stored in a relational database. It gives you an idea of the kind of metadata that we would need to store, such as configuration information, settings, shard maps, and shards. We don't go into this much detail because we're going to just focus on the demo. We've only got 45 minutes, so let's get cracking at the demo. But I want to share that with you. All good to go.
Excellent.
This. Okay, so what we've done is we've taken AdventureWorks OLTP database, and we have sharded it. And it's the AdventureWorks 2012 OLTP database. It's not the OLTP Lite database or anything to that effect. It's the full AdventureWorks database. And just to give you a sense, or to kind of prove that what we did there, let's have a look at these tables here. And this is the root database we're going to talk about or refer to. Inside there are our data elasticity metadata tables. These could have been in a database all on their own. You can do this with SSDT. You can bring it into your roots, into your root database. But just all the database, the tables you would have found in an AdventureWorks database. Now you'll see that while we have production here, we don't really have the customer here, or we only have a few of the person. That is because those are sharded tables. These are tables that we have just left in the AWMA. But just to be very clear, this sharding sample is on a non-trivial database. Oh, I'm going to have fun with that today. Okay, so the next thing that we want to do is, in Visual Studio, we've just done these test methods. We're not going to go into each one of these. These are pretty simple. We're just going to execute this, right? We're going to create the initial environment. So what does that mean? I'm popping over here to is the settings. If I execute settings right now, these are all against my Azure SQL Server out there. I've got nothing in settings. We've got absolutely nothing in configurations. And just to let you know, we've got this currency table, which we'll talk about later. It's empty. So we haven't initialized this environment. We've just done some setup so that the demo can be going faster. When we initial the sharded environment, we're going to run this test. It's going to run around in the background. What we're doing here, hey man, what we're doing here is, as you can see, I was playing around with this earlier today. It's in Azure. These are what we're using the table store from the table library, and those databases are going to be they're queued, and we've got 3 worker roles happening in the background there, and they're busy creating the databases. So we're essentially provisioning the databases. Some of them are completed already, and they're queued, and we are creating 5 shards. And if we go to the databases here, we refresh that, and you got your 5 shards. And let's have a look what's inside one of these, right? There's the tables that we have here. Sales order, production, product. These are going to store customer information and the sales order for these customers. What we've also done is created this shard that is a high volume. We call that a pointer shard. And what that high volume shard does is you can take a shardlet and say, I don't want that to be having noisy neighbors, or I want that to not be only on my shared basic databases. What I want to do is I want to store that on the P1 or the P3 or my high skew, right? That's the most valued person approach that we use there. If we look at the settings, we can see that we have, from a security perspective, Superman is the admin user here. You can create databases, you can push DDL across, and Batman is what the users, when they connect in, will actually connect to the various databases to get the information. From a configuration perspective, what you'll see here is that we can have servers that can host the databases in any way, in any place, in any data center, if you like. We have the configuration, which will tell us, do we have a lot of, what's the target number of shards that we need to create. So you might say, I want to create 100 shards, and the shards are getting created. At any point in time, you can actually see what number of shards are there. You'll see this table here. He's actually a property bag, if you will. People choose to deploy the databases through script files, through SSDT, however they want to. And they may need settings like we've needed here to say, oh, we're going to publish it to this XML. So these are the properties when we deploy our database. It's essentially a key value pair. You can set what you want to do. Here are the databases and the ranges. And as you can see, we're using integer ranges on this side. And there's our database for premium speed orders. Scott, anything that I might have missed?
No, I like this because what these are basically does is these are all the metadata settings for, look, how many shards do I want? What's my threshold for when do I need to create a new shard? And this is all important information for when you for following these best practices patterns, right? And this is all necessary information. So it allows me to set my thresholds and my mins and maxes for what causes a scale in, right? And elasticity. So this is good information. But we're just getting to the good stuff too, right?
Yeah. And
other more exciting part.
Okay, so what we're doing, I'm just pushing this test off. This update reference test is taking, I showed you earlier on that there was a, oopsie, not there. The currency rate in AW main was actually empty. Now it's busy loading and it's 220 rows. You can see 220 rows are happening here. It's busy loading here. And what's going to happen is when it hits 500 rows, then we will have seeded our golden copy root database. It's in AW main. This is our golden copy database. And at some point, we're going to start synchronizing these tables with that information that we got out of. There, you see it already. Now we are populating 1 and 2 with currency rate data. And the others are queued. Let's see if I've got one here already. I did prepare this today. There's currency rates. This should be empty. Should be empty. But number 1 should be currency rate on 1 should be full, right? There it is. So AW1 is full. So have a look at number 5 again. Voila. So we have pushed out those 500 rows out to all of the shards. Scott, normally this is a previous time we said what we were doing here was that these are these reference data tables that are non-volatile but can be, updated in the evening or updated on an infrequent basis, and that's what the technique you would use is we push this data to the table and we merge it with the production data so people stay online.
Yeah, correct. And this is fascinating because it allows it, and notice how fast that was, right? Very, very efficient, very quick.
Yeah.
Right? If we need to make a change, we'd roll it out to all the shards.
Yeah. We've applied some best practices there where we don't go and directly load the data straight into the production tables. We load it into the staging table, and then what happens, we BCP it into the loading staging tables, and then we use a merge statement to efficiently update the production data. I'm going to kick this test off because it takes a little while. I did reduce the load size. We are in this code. All we're doing is I'm adding test number 50 test customers. Each one's going to have 5 orders, and we're doing it as a single thread. So there's 2 things here that are interesting. Scott, you're going to see something here you hadn't seen before. So I'm pretty excited about this one.
Sweet, wow.
Sharded connections. So what we're maintaining, look at that number, that split is changing. So what we're doing is we can tell you that a shardlet, namely the sharding key, is connecting to that catalog and it's touching that sharding key. And this becomes important when we're moving data around, because at some point we need to know that that shardlet cannot be accessed, right? So where's my, this shard, I was looking for something else. It's not here, so I'll just go here. Shardlet map, that's what I was looking for. Oh, there it is, shardlet map. If you look here, these are all the shardlets that we've created. And there are 17 pages here. Or is it rows? No, that's 18 rows. What's that? There we go. So these are the shardlets that are getting created. You see it's active. Now that it's active, that connection, any connection that wants to come for this sharding key can immediately start doing transactions against this. And they will be directed to sharding catalog number 5. That status field is going to tell us if they're active, and so when we're moving the data, then they can't access that, just that shardlet can't be accessed, and that'll be to moving. All the other shardlets will still be able to access their data, even though we're doing splits and mergers and so forth. There we go. So obviously your application would do multiple, you're going to do multiple connections. Like this would be multiple connections going on. Okay.
Right, and I think the key important thing here is that as long as those are active, you can each one of those shards can take connections. All right.
Yes. And that we create this kind of ability to say a connection is connecting to a shardlet, which you can't do today on the SQL Azure directly, right?
Right. Oh, absolutely.
Yeah. So this test is still running there. We did reduce that there. So let's go and have a look at some of our orders that we got. This is on the shard 1. We can see we've got 55 orders on that shard 1. We've got on shard 3, and I purposely chose 3 for later on. You'll see there's 60 orders that we've got there. So we're distributing. You can see. Does this show where the customer ID on this one? Customer ID 5. There we go. Okay, that's done. So one of the things that we want to do, one of the things that we want to do here is take a shard, and we're going to pick number 1, and we're going to pin him. And this is the one where we're saying, pick your customer in this scenario who you want to put onto a SKU. I've had a customer who's going to run a campaign, and for a period of time wants to move that shardlet to this high-end SKU. Let them run their campaign. Let that shardlet have all the performance they need, and when the campaign's finished, bring their customer back into the shared world. And we don't want them to be moved around, so we pin them to that high-volume shard. So we're going to do that. This is pretty quick. So before we do that, let's go to dump sales orders, and we've shown this already. There's 60 here, and customer ID 1 is inside here. We're going to have a look at our pointer shard, and you'll see that there's nothing here. So we're in the high volume database, right? And let's do the test. And essentially what happens here, it gets pushed onto a queue, the queue picks up that shardlet and moves him across. And it happens too quick for me to actually go into my shardlet moves table here to to show it in progress. But what you'll see is that it's pinned, it's true, the move is complete. So let's go and have a look at our records here. AW high volume. There he is. There are the records. If we go to dump sales orders, remember he was here. We said 60 order header count. 55 order header count because that customer had 5 orders. It's moved.
Yeah, very nice.
Yeah. So now we're going to do a scale out. And I kind of raced this so that we could be finished on time for that. So, you know, be sure to ask questions as we're going along here. But we're going to increase the shards by 3. We're going to increase them from that were 5, we're going to increase it to 8. So you can imagine if you had a UI, you wouldn't do it like this. It would be a simple matter of saying, oh, I want 10 shards or I want 12 shards. That's what you want, right? And this is the code to achieve that. And when we do that, we first deploy the shards. So we deploy we deploy the shards, and that means that we create the databases and we make sure that they are available, and the connections are still connecting, data is still getting added. Nothing is actually unavailable. Everything's still available. We then publish the shard, and the minute we publish a shard, only then can the new connections actually start making use of those new databases. So you can imagine now what happens is I've got 100 customers out there, and they spread over 5 databases. I'm now going to deploy the databases. They're out there. You're paying for them. They've got all the reference data in them, but they're not getting used just yet. Okay. Now I publish the shard map. Now, all my old data is really predominantly in those original 5 shards. They're still there. But my new data, my new connections are coming in, and they're getting distributed between those 8 databases. So you're already getting a release, right? So that's happening. Then we actually start moving the shardlets. So we start rebalancing the shardlets. And they're happening as shardlet per shardlet per shardlet. So if you want to do many shardlets in parallel, you can do it one or two ways. One is you can increase the number of worker roles that you've got out there. Right now we've got 3 worker roles running out there. Or you can increase the number of threads that are processing those queued items. You can increase the number of threads on that so that each worker role does more shardlets in parallel. So let's just kick this off. Run tests. And in the background, we can have a look here. Nothing's really happening here because it still gets deployed. We go to our shard creation again. We're going to execute this. And now you notice that it's been queued, right? So 1, 2, 3, 4, 5, 6. That is the 5 range shards and the pointer shard. There they are there. And now we are queuing this. So why do you see this twice? That'll be a question, right? We have a setting, and we've chosen to do this. It's a setting anybody can apply when they're using this pattern or the sample code. Is you take a DAC pack, validate that the schema is the same, and let's synchronize it. So that setting just says we want to synchronize. Every time we're going to create new shards, we're going to synchronize that. For something like this database, well, there's nothing to synchronize. You just create it right up front. And as you can see, we created those databases, and they are pretty much complete. Just this number, who is this now? His number for 8 is just taking his time. In the meantime, we can go and have a look at our databases here. And there's 8. Now understand that you want this to finish because once you apply the DAC pack, there's other things that you want to do. So you want to synchronize the reference data, you want to create users, all that kind of, all those kind of processes. And it is taking longer than I'm normally used to. Okay. Here we go. Okay.
This is really interesting. What I like about this is it's, while you're doing it, manually, this can all be done dynamically, right? I need to go from 5 to 8, that back down to 3, all dynamically based on our metadata, right? Based on the thresholds that we set.
Yeah. And so what the pattern allows you to do is you can use performance, which is using the DTUs. So you might want to have a trigger that when you're getting too many hit close to your thresholds, now you want to increase your shards.
Right.
There could be business rules as well. When you've got so many tenants or so many shardlets in a shard set, now you want additional shards to be created as opposed to it always being a manual job. Now,
right, and that's great flexibility there. That's what I like.
So now remember we're in database 1. We've got 8 databases now. 9 because we've actually got our high volume, and we had 55 order headers in here. So we should see this reduce. There you go. It reduced to 40. Let's go and have a look at that was short.
So what it did, it moved all the shards and shardlets and redid our map, correct?
That's correct. Yeah, down to 30.
Mm-hmm.
And the important thing to notice as well is that this pointer shard header here, which is that one individual we sent here, did he get affected by this range-based sharding that's happening? No, he's still there because we pinned him, right? That's exactly where we want him to be. Okay, and let's see if, and there we go, just took its time. Okay, so there we've essentially scaled out. And what we're now going to do is we're going to scale in, and this is the merging, right? And we're going to move from 8 shards down to 3 shards. And the same principle, right? We're going to deploy our map, our shards, and in this particular case, all it's doing is synchronizing the first 3 shards, and then when it's finished doing that, it's going to publish a shard map. And the publishing the shard map, just to remind again, is you publish the shard map, and then so now new connections will not go to the remaining 5 shards inside that range. They will always hit the first 3 shards that we're setting up here. Those first 3 shards, and all your other shardlets are actually going to be set up to do the move. So we can go and see if we can actually see those shardlets in the move. So I'm running that test. The shardlet moves. You can see we've got lots of shards that the shardlets that we moved in the past. Go to the shardlet map. We spoke about them being active. Let's see if there's any that we can see that are in a moving status. And the last time Scott and I did this, it just happens to, you can't,
it's so fast that we couldn't say anything, right? It moves that fast.
Yeah, and I know there's a way to get it, but I didn't want to change the prep that we had done for the demo. Change.
Probably a good change.
Yeah.
Yeah, probably when we went to the end, we might see something, right? There's 30 pages. Yeah. But that's what's really nice is the move is really that fast, right? We could probably go back to SQL Server Management Studio and see that.
Yeah. Sorry.
The fewer number of databases, right?
Correct. So we're going to go there now. So it's coming down, right?
Yep.
That process there. So this will not drop. This will not drop a database unless it's empty. We've actually done a test. We just don't do it in the demo here. Where what we do is we demonstrate that if you pin, remember we pinned the shardlet to the high volume database, but you could have pinned it to a range shard. There's nothing stopping you from doing that, right? And that, if you had done that, so let's say we had taken that pin and we pinned him to shard 7, and now we were reducing the shards to 3. We would reduce the shards to 3, but you'd still have number 7 still sticking out there because he's containing that particular pinned shardlet. What you would want to do is move that shardlet to a different database or to one of the other range shards, or you may want to even keep it there. And that would be something you need to manage. You get advantages of pinning shardlets and doing this kind of lookup of sharding. You get advantages of doing that. But at the same time, you do take an overhead of now manually having to manage where you're going to place your shardlet. That's why we like, from a pattern perspective, we like to separate this out into having a pointer shard, if you will, and having separate range shards. And then you can place all your pointer shards to specific databases. So if we look here, you want to do a refresh here. There we go. There's the 3, right? So pointer shard, did we fiddle with it? We're going to run it again. That same pin shard still sits there. We go to shard number 1. Now we've got 85. Shard 3, remember you had 30, 75, and then of course it's just pointless trying to run it on shard 5 because that database just doesn't exist.
Sweet, so we're down to 3. Awesome.
So we're down to 3. And what we've done with the configurations is you will see a history of all the configurations that were taking place. So you will be able to essentially log, hey, what was the sequence of what was happening? When did things happen? Why did they happen? It's not so much about a when as much as it is, this was the setting we had, now there's a difference, is a new setting. So we've had 3 shard maps actually get generated here. There's the shard maps, there's range values, they're different. So shard map ID 2 has got 3 shards, shard map ID 1 has got 1 shard, it's got 5 shards. And sorry, 2 had the 9 and 3 had the 3. My mistake, my apologies. So I've purposely tried to race through this to keep it as high level as we possibly could, but at the same time leave room for questions. So how does that get managed here, Scott? How do we do that here?
That's a good question. I think, Neil, how do we get questions from here? Can people unmute themselves and ask, or do they post them to, is there a question?
So that's a great question. Thank you, guys. Yes, we can post questions in the GoToMeeting session controls. In the question tab, you can open it up and post your question in there. We do have a couple already that have come through, and I can, now tell you what those questions are if you're ready to take those, and we can go through the Q&A section now.
Yeah, sure. We try to leave some time for Q&A and
sure.
So we're
Excellent.
going to kind of run through this, so shoot.
Okay, so let's go with the first question here. So the first question is, we know federations were bottlenecked. Can you characterize any disadvantages of this approach? And there's a follow-up question to that as well. So I don't know if you want to kick off with trying to answer that one.
Okay. So federations is bottlenecked for a number of reasons. There's a gateway that was involved in that as well. And one of the things that it was doing that this pattern doesn't do what I'm about to describe. It doesn't filter your queries so that you can only get the results of a shardlet. So let's say you did a connection for shardlet 5 and you connected to that particular shard. Then once you're there, you can run any query you want to, and you can access any other shardlets inside that database. I'd recommend you don't do that because it's just looking for trouble, but you're technically capable of doing that. What I've seen in forums is a word they call that the data leak, or cross-tenant data leak, something like that. There it is. The question was, was there a bottleneck here? We haven't seen a bottleneck in this. We've had a number of customers, they take this pattern, they take what they want out of it. People still create their own custom sharding ways of doing things, and we have not yet found anybody who's hit a bottleneck. I have one customer out in Minneapolis, I think it's Minneapolis, and what they have actually seen is a marked improvement in terms of they migrated from federations to custom sharding. They use a lot of these techniques, and because you've got this cache layer for all those shard lookups, these are sub-millisecond, in some cases sub-millisecond operations to find out which shard a connection should go to. Does that answer the question there?
Yeah, I think it did. I think
I
one of
think
the
it
bottlenecks.
did. We do have so there's a follow-on question to that. What are the next steps in terms of perhaps a step-by-step walkthrough of documentation, and will this solution be supported? So I think it's trying to figure out how we can kind of maybe utilize this for that purpose.
That's a great question. So, so let's answer one part. The one part of the question is documentation. The other part of the question is about supportability and what's essentially the future of the solution, right? And I think the first part of the documentation, we are working on reviews right now of the documentation that we've had. We've got one document that is a step-by-step, exactly this demo. So we literally go step-by-step through the demo. We go a little bit deeper and explain why we do things or how things are done and what references are used or classes that we use, so you can really dig into that code. The other documents we have is, remember at the beginning of the demo we spoke about terms and diagrams and so forth. Same thing, right? We do a document on sharding concepts and sharding thoughts and experiences that we had, some best practices that can be applied to pretty much any custom sharding project you take on. And there's other ancillary documents that we will share with that, and those are all under review at the moment. The question about supportability of the solution, this is, as per our team and what we do, this is actually a pattern that we are sharing with the community, our lessons about working with customers. This is not something that we are, we're not let's say a product team that's dedicated to work to creating this content for supportability or product launch or anything like that. With that said, Microsoft is looking at what can we do and what is the work going forward about creating a data elastic team, and that is high priority for people. This content, people using this content, actually feeds into those teams so that we can we as a company can create a product that people use and can trust, and it's reliable.
Excellent, thank you for that answer. It appears that all the questions we have now have been answered. So at this time, I think if we can maybe move to the final slides and kind of bring that information up. There is actually another question that's just come through as well. So I was going to phrase that one as well. How UI dynamically retrieve the requested charlotte. So I'm not sure how, if that's kind of been phrased enough for you to be able to answer that one.
So if I've understood the question is, how do I get the connection to the shardlet? Say the question again to me quickly, please.
The question, how UI and dynamically retrieve the requested shardlet. So maybe we need a bit of clarity on that question, possibly.
Yeah. I will say this, is that what we've done, and it's a pity I didn't mention it earlier, is the way the pattern works is that you will call a SQL, you will call an elastic SQL connection. When you provide your sharding key, because that's what you use to identify the shard that you want to get to, we will return a connection. If you're using something that already uses reliable SQL connection, such as Entity Framework, we will return the connection as a connection. That is the SQL connection object. We, in the pattern, include the ability to call a reliable SQL connection as well. So you have the ability to choose whatever it is you want to use there. but you would have to look into the code to see how we call that elastic SQL connection. And like I said, that code is, when you get it, is available. It's not black box.
Excellent. Looks like that question was about what you just answered, so that's great. So without any further questions, I think we can wrap up here. I know you guys are going to jump on to the very next session, so that's probably a good time in there. I do want to thank you for some excellent session and material provided today. You guys have done an excellent job, and it was a pleasure to be a moderator for you. Hopefully, I'll be on in a couple of hours myself, and I'll see you guys at PASS. Any questions that you didn't post today and you want to get through to the guys, do post them on PASS 24 hours of PASS Twitter feed, hashtag, and we will be able to hopefully provide those to the speakers. Again, once again, thank you to Scott and Sean there for providing the material today.
Awesome. Thanks, Neil.
Thank you, everybody.
All right, thanks.
Bye.